Space. The final frontier. Except we don't have cool spaceships because the US government has a bit of a thing for aircraft carriers, F-35s, and ships bristling with guns. The United States spends roughly $600 billion per year on the military, which is about 54% of the annual discretionary budget. By comparison, NASA only gets $18.5 billion per year, or less than 0.5% of the national budget. Now, we're not going to get tied up in debating whether or not the US needs such a massive military, but here's some quick facts in case you're interested. The next biggest spender is China at $190 billion per year. China has 500 of their Type 99 tanks, which are outclassed by the M1 Abrams, of which the US has 8,700. The US has 10 aircraft carriers. The rest of the world combined has 10. Smaller ones. There are 8,400 attack helicopters around the world. Of these, the United States owns 6,400. And those are just the vehicles. One single Tomahawk missile costs around $1.5 million. Then you have paychecks, fuel, ammunition, and all the rest. All those expenses add up to that whopping figure of $600 billion per year. For a little perspective, the entire cost of the Apollo program was about $136 billion in 2007 dollars. $136 billion over 13 years, or just over $10 billion per year. Picture a clock representing $600 billion. 1 minute on that clock is $10 billion. One of the greatest scientific achievements in history fits into that tiny sliver of the US military budget.
What if, due to a printing error in the federal budget, all the money destined for the US military went to the space agency instead? What would $600 billion pay for? Not only would it allow the space station to remain up and running, but it would also allow them to send more astronauts. And there'd still be enough money left over for NASA's biggest ongoing projects. Developing the space launch system that would carry us to the moon and deep space? Not a problem. And then there's Mars. Together with SpaceX, NASA could restore the uncrewed Red Dragon mission that would mark the beginning of Mars colonization. Sending the first humans to Mars would cost NASA around $450 billion. With $600 billion of annual funding, a crewed mission to the Red Planet would become NASA's next Apollo very quickly. We'd build a human colony on the moon, turning it into a base for our trips into deep space. It would also serve as a blueprint for Mars colonization. We'd move up the launch date on the Europa Clipper, a mission to Jupiter's smallest moon in search of signs of alien life in the oceans of liquid water beneath its icy shell.
Humans dream about leaving Earth and traveling through the galaxy. But we were born too early to be part of it. Or were we? The reality is, we could begin our dream by building a moon base today. We actually do have the technology, and current estimates from NASA and the private sector say it could be done for $20 to $40 billion spread out over about a decade. The price is comparable to the International Space Station or the budget surplus of Germany in 2017. Not that big an investment, really. The payoff would be immeasurable. The moon is a sandbox to develop new technologies and exploit unlimited resources. It would start a new space race and lay the foundation for us to spread out into the solar system and beyond. It would create a vast array of new technologies to benefit us on Earth, and we would all be part of it. So why aren't we doing it? If we start today, how would we build a moon base? Throughout history, colonization happened in phases. In the first phase of the age of exploration of the New World, for example, European monarchs funded expeditions to chart and discover and to stake their claims. They planted a flag and set up a camp, but they didn't stay. In the second phase, small missions set up outposts and settlements were founded, which were still very dependent on their home countries for supplies. Some failed, but others survived and established a permanent presence. Only then, in the third phase, did a true colony form to which tradesmen and labourers could emigrate, creating new wealth and opportunities for themselves and their families, sending extreme wealth back to their countries of origin. When we colonize the moon, we'll go through the same three phases, this time without murdering millions of innocent people in the process. We're good at doing hard things. In the first phase of lunar colonization, our explorers proved it can be done, that a new world can be reached. This phase started 60 years ago with the Apollo missions. Since then, satellites like the American Lunar Reconnaissance Orbiter have mapped the moon, while rovers like the Chinese Yutu have studied the composition of the lunar surface, looking for water ice and metals. Phase 1 is more or less complete. We know what we need to know to enter Phase 2. In the second phase, astronauts will build the first moon base, and this could begin today. The first small moon base could be completed in a decade. The first nation that establishes this base will be akin to the First Nations building outposts in the New World 500 years ago. It's expensive to send rockets to the moon, so we will send as little as possible. The base will be light, little more than inflatable habitats for crews of no more than 12, and will be deployed somewhere with natural shelter. Options include caves, like underground lava tube tunnels or craters near the poles where the days are 6 months long. These astronauts will not stay long. The habitat is likely to be abandoned between missions, as solar panels cannot generate electricity during the lunar night. But they'll do the groundwork to enable humans to stay permanently. Our first crew will consist of scientists and engineers who will study the composition of the moon and whose experiments will explore ways of using the available lunar material, say purifying lunar ice and turning it into water for human use. And water is important for far more than drinking. They can use it to experiment with growing plants for food. Hydrogen fuel cells will store power through the long night, extending astronaut stays. And most importantly, it can be split into hydrogen and oxygen, rocket fuel. By harvesting water from the moon and putting it into orbit, the moon base will supply an orbital depot where scientific missions to Mars and the outer solar system can refuel. Compared to the Earth, it's much easier and cheaper to get things off the moon into orbit. Colonizing Mars may mean starting from the moon. But this isn't a true colony, not yet. The base will be abandoned if funding stops. If we want our base to grow into the third phase, into a true colony, it must become self-sufficient, supporting itself via exports to Earth. What can they get rich on? They could extract precious metals, abundant in impact craters, and other raw materials from the lunar regolith. One promising possibility is the mining of helium-3, an isotope that could one day be used in nuclear fusion reactors, something the Chinese lunar exploration program is currently looking into. Future colonists may export helium-3 back to Earth, providing us with cheap and clean fusion energy. Asteroids could be pulled into the moon's orbit and mined. With commercial exports to Earth, the colony is fully in its third phase, self-sufficient and economically productive. Our base will begin using lunar material in its construction projects if it's to continue growing. Fortunately, lunar soil has all the necessary ingredients to make concrete. Robotic mining rigs can sift the lunar dust for organic molecules and could be used to build huge structures way too massive to be brought from Earth, while advances in 3D printing will make it possible to produce almost everything else the crews need. It's hard to say when exactly the colony becomes self-sustaining. Growth is gradual, experiments are replaced by industry, and the population steadily reaches the hundreds, encompassing more than just scientists. Engineers, pilots, and contractors representing countries and corporations will be present. Two of these people will make a breakthrough. Not scientific, but social. They will have the first extraterrestrial child. Throughout history, the birth of the first child was celebrated as a moment where the seed of a colony finally and irreversibly took root. Here, it means that the moon is not just a place for scientists and engineers to work, it's a place for people to live, to raise a family. Once this transition happens, the colony grows rapidly, building more habitats and schools and farms and all the things needed to support the growing population. As our colony grows, all kinds of new technologies will be invented to sustain it. They might develop crops that efficiently recycle carbon dioxide or that grow with very little water. They might find ways to recycle and reuse 100% of their waste, technologies that are extremely valuable for Earth. They could even build the first space elevator in the solar system. With a space elevator, spacecraft, astronauts, and raw materials could be brought back and forth from lunar orbit without needing to use rockets at all. The moon may become a hub for economic activity on a scale that's hard to imagine right now. The Moon is a perfect sandbox to learn how to colonize the solar system, the perfect project to unify nations, and the only way to guarantee our survival as a species should something tragic happen on Earth. If we ever want to colonize the Milky Way, we'll have to start somewhere. So why not start there? Why not start now?